Hello, everyone, and welcome to today's webinar. I'm Milan. I'll be the MC for this morning, afternoon, evening, and I've got Vasilii here with me, who's going to be our main speaker for today, talking about the latest JavaScript analysis that we've done, specifically focusing on how we're going beyond just our benchmarks and how we've actually detected real vulnerabilities at scale with Semgrep's analysis. As for some quick intros, I am Milan Williams. I am a product manager here at Semgrep. I'm responsible for Semgrep Code, our SaaS product. And Vasilii, do you want to introduce yourself?
Oh, yes. My name is Vasilii Ermilov. I'm a security researcher at Semgrep. I'm responsible for everything around the rules, so rule production, testing, etc. So when you scan with Semgrep, have findings, yeah, I'm part of this deal, so yeah.
Absolutely. Vasilii is an extraordinaire around here at Semgrep. Some housekeeping things before we get into the content. The session will be recorded. I saw that in the chat. And if you do have any other questions, just drop them in the chat. That's where I'll be looking, and I'll try to answer them as they come in if they relate to what Vasilii's talking about. Otherwise, we'll leave at least 15 minutes at the end for any questions you have. We'll stick around. With that, let's talk a bit about Semgrep. In case you're new and you haven't heard of us before, I figure it's worth talking about who and what we are. So Semgrep is an AppSec platform. We have 3 products within our platform: Semgrep Code, our SaaS product; Semgrep Supply Chain, which detects third-party vulnerabilities in your dependencies; and Semgrep Secret, which scans for exposed credentials in your code base. All 3 of those products are powered by our Pro engine, our proprietary engine for deep analysis and managed scanning, which helps you kind of one-click roll out Semgrep across hundreds of thousands of projects. And then all of that is layered together with our assistant, which we'll talk about as well in this presentation, but is our AI-powered triage and remediation recommendations, which helps you not only find the findings that matter, but help you give the instructions you need to your engineering team so they understand how to fix them. And all of that is wrapped up together in the Semgrep platform, which gives you kind of one command center for everything with both the findings you found so far and the remediation progress. But the main principles that we kind of go by within Semgrep are these 3 ones. So we focus on telling your engineers, like, we'll never ask you to leave your coding environment. Developers are never expected to do their own research outside or context switch. We're right in their PR, in their IDE, and in their kind of integrations, common integrations. We also will never tell you what to change. If we can't tell you what to change, we won't show it to you. We'll always give you clear step-by-step remediation guidance for any vulnerability that we think is important. And number 3, we'll only ask you to fix things that we think are critical. We're only going to notify any engineer of something that we think is critical, that we can prove is exploitable. So those are the 3 main principles we have within Semgrep and what makes us unique. With that, I'll segue to Vasilii to talk about how we've taken these overall principles and looked at them within the JavaScript analysis that we've done and how that makes our coverage unique.
Yep, cool. Give me a second to share my screen. Just a second. All right. You can see it. Slideshow. Okay. Let's go. Where are my slides? Must be here. Okay, everything works. So, okay. Hello, everybody, again. So today I want to share the story of how we improved the language support for JavaScript and TypeScript, which steps were required to do it, which vulnerabilities we now can find with it. Yeah, all of that. So let's start. First of all, I would like to say that, about our motivation here in this project. Small wonder that JavaScript is one of the most popular languages in the world. It was number 1 for many years. Now we have TypeScript growing very rapidly. I think that if we merge the numbers together, it will be number 1. And because of that, the language popularity is growing. So the more vulnerabilities introduced, and it kind of works both ways. More vulnerabilities introduced, more vulnerabilities found. We have more bigger attack surface. So everybody is interested in securing JavaScript and TypeScript code, and that was our main motivation to make Semgrep's support better for those languages and make our coverage level up. And when we talk about coverage, I want to first of all clarify what we mean by that when we talk about Semgrep. And so coverage consists of two main parts. First is Semgrep engine capabilities. It's a Semgrep Community Edition engine, Pro engine. So their capabilities on how they can parse the code, kind of understand the code, if you will, and the second part is the rules that provide intelligence, what vulnerabilities to find, how to find them, where to look for them, etc., etc. So, and together with the engine support and the right rules in place, we have a combination that provides meaningful output, meaningful results. In our case, findings. So, moving on. First step for us was to make the engine support better and suitable to parse JavaScript and TypeScript at a high quality level. And the first feature that we decided to implement was support for callbacks. I think that it's safe to say that every single JavaScript project, one way or another, uses callbacks. If we talk about projects that were written or started before ECMAScript 7, those projects, they heavily rely on callbacks. And yeah, so support for callbacks, support for being able to propagate a source of input through the callbacks was important in order to not miss any findings, not introduce false negatives. Here on the slide, we can have a simple example of such situation where the source is going through a callback function here, and then it is ending up in the sink. Let's say it's some dangerous sink that you want to highlight, and because of the fact that it's used inside the callback and this value is passed, now the engine is able to understand that when the taint value goes here, it actually ends up here and then in the sink. But this is the simple example. Of course, the engine is able to tackle more complex situations where callbacks are chained together and being able to propagate through so-called callback hell. So give me a second. So that was the first step. Another important feature is actually a long overdue model resolution. So as you can see in the pictures, we have different ways of importing FS module, FS dependency. So let's say you have a project with FS library and you want to write rule or you want to find where this library is used. And previously, for the Semgrep rule, we first of all, researchers and people who write custom rules, we had to write many different ways of how the dependency can be introduced in the code. Usually separate one for the require, another one for the import, including many different code patterns. And by the way, on these pictures, it's not all of the possible ways. It's twice more, maybe it's 3 times more. And in order to not have false negatives again, in order to be able to quickly find all of the occurrences of a particular library in the code, we created a pattern for the meta variable, new Semgrep pattern, that is dedicated exactly for this purpose. So you can see here we have meta variable fs that, and we say to the agent hey, this meta variable must be a dependency, this one or this one, whatever we want. It's better to show on the example. So this is the same meta variable. So we have a pattern, let's say fs open. So let's say we want to find this part of the code, in our code base, we want to find open function used, and we want to make sure that it is coming from the FS dependency. We have this pattern, pretty simple, and we specify that FS must be coming from this library. And this one pattern will work for the situation like this. It will work for the code like this. It will even work for the code like this. It's all tackled by the same meta-variable pattern now. And it's gonna be able to find, I think, maybe 99% of the situations where a library is used, maybe only like bad practices, edge cases where maybe like the library is imported dynamically, like in the code, like avoided, but in general, it's like a huge step in the identification of the libraries and their usages. So on top of that, we just made some bug fixes, general improvements in the taint mode, in the the tracking data flow between sources and the sinks, including, for example, opportunity to have data flow between the code bases that uses JavaScript and TypeScript together, like mixed together. Sometimes it happens, so we're ready for that. Yeah, moving on. Okay, now when we made all the right improvements to the engine and we were ready to go to the next step of writing rules, we at Semgrep, we decided to focus our effort on writing rules for server-side, for Node.js ecosystem specifically. And this is due to the fact that client-side code, the JavaScript that runs in the browser, it usually the danger of it, the danger is for one user at a time usually, because it is mostly XSS vulnerabilities, maybe like a few other small weaknesses that also ends up being XSSs. And on the server, on the backend, there is much bigger variety of potential vulnerabilities, and the impact is usually much higher. And we wanted to scope our work to be impactful and valuable for our users. So we decided to focus on server-side code this time. However, I want to admit one thing, that because of all the engine work and us working with the language, testing it, the language support became better in general. So you can still write custom rules for front-end code if you want. We have rules for front-end libraries like for React, like here's the example, for Angular, I think, and a few others. So feel free to refer to the registry and find the rules if you're interested in the front-end code. And as I mentioned earlier, the support for the language became better in general. But moving on to the server-side code. So what does Semgrep's coverage include for Node.js ecosystem? We decided to focus on these frameworks. Express is an absolute leader, the most popular framework in this ecosystem, I think. Nest.js is also very popular now. It actually has more GitHub stars than Express. It not necessarily means that it's more widespread, but it's definitely getting more attention and become very popular. We also introduced support for Happy and Core.js, mostly based on the feedback from the users and demand for these frameworks. They're still in the game, so why not supporting it? Okay. Also, in terms of the coverage, everybody wants to see OWASP Top 10 coverage all the time, but unfortunately, it's not not every category of OWASP Top 10 can be effectively covered by a static analysis. So we focused on those parts that we can do good. Of course, on the injection, SSRFs, which are also injection sets for me, but okay, it's a separate category, no problem. Some logging, different kinds of misconfigurations, cryptographic failures. Also, as a side note, I want to mention that for this category, for vulnerable and outdated components, we have a separate offering. So if you want to remove this problem from your organization, feel free to check out Semgrep supply chain. But we're moving on, and I prefer myself to look at the list of CWEs, the list of weaknesses, because it gives you more realistic picture of like real things that we try to find. Yeah, because OWASP categories are usually very very broad. And as you can see here, as I already mentioned, a lot of injections of all kinds, XML rules, rules for insecure cookies or lack of secure features in cookies, cross-origin requests, configuration course as well. And actually, while I just noticed recently that while preparing the slides, while we were preparing the slides, we actually introduced and pushed to the production a few more categories of rules, so it's even more. Feel free to refer to the documentation. There will be links. It has the most recent information about our coverage. Okay, so when we know what vulnerabilities we want to tackle, what we want to find, the next step is to scrape the NPM, identify most popular libraries that are the most used by the community, and extract potential things from them, potential dangerous functions, and which vulnerabilities they will stand for. If we count together with the Node.js standard library, we now have more than 50 libraries supported. Here's some examples. You can see more in the documentation, as I already mentioned. Yeah, feel free to refer to it. The list is still work in progress. It's getting updated all the time. Okay, so moving on. When we got all the things in place, when we made the research on the frameworks, understand where the input is coming from, when we connected all the dots together and came up with the rules, it's the time to test them. In order to evaluate static analysis tools, or any security tools, people usually use benchmarks or purposefully vulnerable applications. Users do it all the time. We do it to kind of check as first step to check where we are at, how we perform. And there are many of those open source. For example, one of the most popular, and I think it's the most popular, not even for JavaScript, just for everything, for benchmarks, is OWASP JuiceShop. However, in its documentation, it says explicitly that it was not built for benchmarking security tools, and this is because it's many times it's actually faking the vulnerabilities. So it doesn't have, in most cases, real vulnerabilities in the code. It just mimics the behavior, and it's mostly suitable for maybe penetration testing, training, or something like that. But people use it. They also use it, and there are some parts of this project that actually have a source code vulnerabilities that are relevant to what static analysis is able to do. This is the list of true positives that we have. More information, you can refer to this table and take a look in the blog post that we released today. It has more information. Okay, yes. So as I mentioned, JuiceShop is the most popular. We need to be aware of it. Also check how we perform on it. I want to show another one. It's actually the opposite of the JuiceShop. It's a very good application called Broken Crystals. It's basically very close to reality in terms of how developers build Nest.js project, and I highly recommend it for source code review practice, or static analysis tool validation for this framework. Here you can see true positives that we're able to get. Yeah, and again, please refer to the blog post for more information. But in Semgrep, we believe that using only benchmarks is not good enough, and we use them only as the first step. And in order to this picture as well, in order to understand how our rules will perform on real code basis, on our users, customers' code basis, we continuously test our rules on a large scopes of open source repositories. We do it from day one. So when we start the project, when we start working, we first of all scrape as much as we can different repos that are relevant to what we're doing, like that have these frameworks in the code, these libraries, and we use it to run, scan, and understand like that the level of false positives that we have, tune the rules to have better performance, and to sometimes not to release something ridiculous, because every rule has like a human being behind it, so we sometimes make mistakes. So just proof that everything works as expected. And of course, doing this work, we sometimes have two positives. We try to spend time from time to time to report them to the maintainers. Today, I would like to share some of the findings, just to like give a glimpse like of what vulnerabilities can Semgrep find, and like how the real vulnerabilities look like. This is like mostly simple examples, because if we go like deep into like each project and like investigate like the 10-fold, it can take a lot of time and be like, you know, like a separate webinar for each finding. It can be so yeah, let's take a look. Here you can see a good old path traversal that is coming from I believe it's Express.js from the HTTP request and is going to the read file function of the FS library without checking if it's the correct path or not. It's very typical vulnerability, happens all the time. So yeah, it can be easily identified as our rules. Another good example of a path traversal, yeah, same thing. Log path is concatenated with the value from the request, and then this file is read, and I'll put it as a part of the response, so you can read any file on the system. Okay, it is surprising to me that people still use, like not still, that people use eval to dynamically create regular expressions, despite the fact that there is a native way of doing it. So please don't do it, or you will introduce a code injection in your code. Another example is, okay, SQL injections are not going anywhere, like despite the fact that libraries, I think all of the libraries nowadays, especially popular ones and different ORMs, they have opportunities to write secure queries, have statements with parameters, etc. Developers still sometimes concatenate strings for SQL queries. Like here, all you need to do is to move this article to these brackets and you secure, and that's it. Of course, not all like vulnerabilities they are like as simple as that. But I gotta say that for Express.js specifically, many of them like live like very close like together because it's a pretty minimalistic framework. Here we have example from Nest.js. Nest.js by its design patterns, by its like structure of the project, by definition, it requires you to have a lot of different files because it has a lot of entities, controllers, services, models, different custom modules. That's why you need like a solid taint mode support for the rules in order to find the data flow and find the vulnerabilities. So here we have such example. It's a controller from Nest.js project, and this is endpoint of the controller that takes HTTP body params and passing them to the service. The service then uses the data repository that is injected, and our engine now supports this pattern which is called dependency injection that is widely used in Node.js. And this repository is used to query SQL database, again with concatenated strings that are coming from perhaps like from the previous slide. So yeah, this is one of the examples that we have. For the full list of findings, you can refer to the blog post. There are, like, we are waiting for a few CVs to be released. It's unfortunately not a process that we control, that we can easily release anytime we want. We have to wait for the response from maintainers. So it will be updated, but the information that we have right now is available in the blog. Okay, so when we look at all of these vulnerabilities, all these problems, you may wonder how to protect, and it's maybe not the best idea, to talk about it in general, because every single vulnerability needs its own approach and its own way of remediation. And by the way, this is why we try our best to provide this information in the findings output, like how to mitigate, what to do, what's the essence of the problem. But if I have to say something in general, I would say, first of all, keep scanning your code, because you see, category injection vulnerabilities for many years, many years, were #1 in the OWASP Top 10, and now it's not. Now it is, I think, #4 or maybe #3. And I strongly believe that it is because of the development of security tools, and that security tools can effectively mitigate those and identify such vulnerabilities. It is, of course, doesn't mean that you need to stop scanning code, like, hey, these vulnerabilities are not a danger anymore, let's just move on. No, it just means that security tools are effective in doing that, and in order to keep the number of vulnerabilities low in your project, such vulnerabilities low, you need to keep scanning, scanning your code. On top of that, I would say, as a general recommendation, sanitize the input. We, as a security researchers, try as much as we can to introduce all popular sanitizers in our rules, in order for you to not have false positives and reduce the noise that application security people have. But we cannot know everything. We cannot know, for example, when you use your own sanitizers in certain situations. But this is where we have our superpower, which is custom rules. So you can customize existing rules. You can add your sanitizers to the rules that you provide and remove the noise. Not only that, but also nowadays you can use Semgrep Assistant. You can ask AI to not show you findings that have these particular sanitizers in the code. And yeah, I guess that will be my main recommendation. One more thing that I wanted to mention, it's just a little observation that we have in our practice when we try to report vulnerabilities. Every single time that we create a pull request with a fix, with a patch, basically, it gets merged or addressed within usually less than 24 hours, usually immediately, without any problem. However, every time we have to reach out to developers or maintainers through the email, or sometimes even security email specifically for security issues, or sometimes we have to open issues in the GitHub. Every time it gets stuck. It takes a long time to be resolved. And I think this is just how the software development works, because developers, they want to do their stuff, release new features, do their work, and they don't like to be disturbed. And in order to have some impact, mitigate vulnerabilities, you usually would want to give immediate actionable items to developers. Best case scenario is a pull request, hey, just merge this and you'll be safe. Or at least detailed remediation steps and explanation of hey, this is why it is bad, please do this and that to remove it. And on our side, we now have Semgrep Assistant that can help exactly with this problems, that can help you create fixes and pull requests to remove vulnerabilities that you find. And yeah, feel free to check it out. It's worth a different webinar, a different presentation. You can find it on our website. I think that's it from me for today. Yeah, we open for the Q&A.
Phenomenal. Great. Thanks, Vasilii. This was great.